Okay, so we're gonna continue part two. Sorry, the part one was the last slide was cut off, but it's alright. We finished it anyway. Alright. So we were talking about tools and techniques, right? Our last slide in part one. So too long, so I gotta cut it in two parts. In here is your CPM, okay? That's your, again, C for critical and P for path, and then M is your method. So in this method, okay, another one is your PERT. In this method, we're using the network, okay, diagram, like a network. So everything, so here you can see the flow right there. So identify all significant activities, all right, involved in the project. So that's what we do. These are our bases for these two networks. We're going to develop the logical, sequential, and parallel relationships among the activities. And then we're going to depict the time relationships on a network diagram. It's just drawing. Then we're going to annotate the activity time estimates on the diagram. We're going to put right there. So now compute the longest, so that's your critical path of activities, but we need this. We need the longest path activities in our project management through the network, okay? Now don't forget, you're not managing whatever project, you're managing a maintenance project. And then use the project network scheme and then related factor computations to plan, schedule, monitor, and control the project times and costs, again, throughout its implementation. Okay, so those are what we do, and these are the basis for these two methods. They're very closely related. So identifying project activities, you have to know your activities. That's every time you think about project, you're going to think about activities. Every time you have the activities, you got to know their relationship. Every time we think about the factor, we're always thinking about the relationship. That's what we're drawing the graph for, okay? Are they linearly related? Okay, are they curving? Is it exponential? Okay, is it like a S curve? So whatever, okay, we're thinking about, again, these are your relationship. Okay, so every time you have activities, so more than one, they're all related. Like I say so many times, you're already learning your basic science, your physics, your chemistry, your biology. Okay, if you can hit all of them, that's the best. But if you cannot hit all of them, you can take like 3 or 2. Okay, whatever your course requirement is, and that's very important because you're learning, like, everything is connected. So now when we think about in project, the same thing, project activities, they're connected. Therefore, they have relationships and we have to know them. Yeah. So in this example of a network diagram, your example, table 8.1. So the common convention of activity on arrow and event nodes will be used. Okay, so the project activity table for constructing a manufacturing plant is your example right here. So what are we doing? Here you're seeing activity table. So therefore it consists of activities. Okay, so what are we doing this table for? We're constructing a manufacturing plant. So let's see the activity. Zoning application, plant design, building permit, plant construction, machinery orders, machinery installation, employee hiring, employee training, and then operational testing. They all belong to construction. Okay, you're constructing a manufacturing plant right there. So that's your activity table. Yeah. And then when you look at it, activity on arrow, event notes. So here, this is your activities. Okay, they're on arrows. These are called notes. Okay, a little round circle one here. Yeah, and those are event notes. So here, when you look at events note, we have 1, 3, 1, 2, 2, 3, 3, 4, 4, 7, 4, 5, 5, 7, 4, 6, 6, 7, 7, 8. Okay. This is just an example. We're going to see the real one in my next slide. Here is activity. We're going to code it. Okay. Somebody wrote something in a test paper, and he said that's not real code. That's a code. Why? Because you're saying A is for zoning application. That's a code. So in computer, we have code 0, yes, and 1. 0, no, and 1, yes. Okay, you have many different kinds of code. Okay, so every time you hide, okay, the long description of that by using abbreviation of some sort or number or symbol, okay, some of the codes use, okay, not a number, okay, not a letter or not a number. They use symbols, yeah, punctuations even. We can code it. So here, that's A, your coding zoning application. B is your plan design. So instead of writing this really long, okay, description right there, we're gonna go with short, yeah. And then you can refer to the activity table to know what's A, what's B, what's dummy, what's C, what is D, okay, what is E. Yeah, so right now we already know A, B, C, D, E, F, G all the way to I is your activity description. Yeah, dummy, zero activity. There's no activity. So here, blah, 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 you can see 0. And here, dummy activity because it's empty. Yeah, nothing here. So anyway, event nodes. So this is who, okay, which event is connected to which event is right there. Yeah. And here, those are just a predecessor that's showing you. So anyways, right now, get an idea of the table, get an idea of what's in the table, okay? And then the terms, your note, your arrow, your dummy. All right, now getting into our diagram. Network 4, we're constructing our manufacturing plant right there. So here's the letter labels. I'm going to start using them. We have A, B, C, and then we have D, and then E, F, G, H, and I. You scan it. Okay, those are your activities. So represented by the arrows. So going that direction because your effect is going to go straight down there due to this activity. Okay, so now you're going to come back into here. So letter labels are placed under each activity arrow in project network diagram. This is your project network diagram in CPM or PERT. Now dummy activities are drawn right here, yeah, with dashed lines. So when you look at it, we have 2 arrows. You already know, okay, one is the solid arrow, and you have the head of the arrow. They are going in a particular direction, going that way, yeah. I don't see anything going backwards. And then we have a dummy arrow represented by the dashed line, where it's in the network diagram. Now coming, continue. So here is a sample of an incorrect drawing. What is incorrect? So let's take a look at it. So activity arrows right there are shown straight lines. Curved lines, see in this diagram, should not be used, okay, in network diagram. You can't draw like this. So I have one student, I was helping him to remember the fishbone that we're doing, right? And you can draw the final, okay, end effect like that with either with a circle or a rectangle or a square, okay, but we don't really draw with the circle, right, for the main diagram or the contributing factor, right, like that. So anyway, you have an arrow right there. So I can't really draw with this thing. So anyway, this is how he did it. He gave me all the bubble, okay, like that. So it's kind of like so interesting. All the students are what they do. Just like make you, oh, how did this person is thinking something that nobody think. So it's like, oh, there it is. Give me a reverse version of right what we wanted to do. Give me really creative things like that. So anyway, it's really creative. It's a great idea, but don't use this, okay? Because we don't put the circle for the sub courses and the major courses. So just stick to our traditional, okay, either rectangle or square. Why? It's because, not to give you a hard time or anything, it's just like if you use a bow, it's just taking more space. Okay, sometimes now you're like drawing a simple diagram, right? Your fishbone sometimes can be like really complicated, like your what should I say, trout bone. Okay, not like the salmon bone. so you have like a lot of little things right there, and then the fishbone or Ishikawa diagram itself is really huge. Okay, it's like a blueprint, by the way, so that you can pinpoint, what goes wrong. So then you track blah 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 blah. Oh, here, this is the one we gotta fix. So anyway, here, do not use a curve. All right, do not use the curved lines. You can't draw like that. I know one of you is gonna give me that. Okay, they're always like so creative, imaginative. Just always come up with something that's going to shock you. But don't do that in your exam, okay? And make sure you draw the straight lines. Now, assigning activity time estimates. So here we might annotate the activity times, okay, as by convention. So we're gonna use like TS. Okay, sometimes TS is like 12, sometimes TA and then TB, so that's just giving you time. Okay, so the time for A, time for B, etc., etc., and then so on. So the project completion time will then be given the notation of a big T. All right, so here you can see it. This is just showing you the time estimates. Okay, starting the time estimates. So here, when you look at right there in this table, you're going to see the activity time. Okay, so this is how the project is going, and those are the weeks in this case. Okay, how many weeks you're going to spend. Sometimes it can be days, okay, and sometimes this can be months, and sometimes this can be year for a long-term project. So here is the immediate predecessor, same thing, the same thing, and this is the same thing. The only thing that changes is the description of the activity. It's now in time estimate, you're going to have the activity time. Okay, now assigning the activity time estimates. So now we're going to assign the activity time estimates. So now the procedure is to track through the network to find how many weeks, okay, the project will require, and which sequence of activities form the critical path, okay, longest, and for the total time. So forward earliest, again, start time for an activity starting at a node, okay, is past the largest earliest finish time definition for all activities ending at that node. So you're going to take this slow, okay, and read carefully. So this is just trying to tell you, so when you take a look at it, okay, you can see that 1, 2, 3, 4, right? A, B, C, your activity going 40, 30, 60, and then the 70, you have 3 week, 4 week, 1 week, 3 week, 2 week, 2 weeks, so and so, okay? So, but here, what we're looking at the note, okay? Note is just the, if you remember the table, you're gonna see the number. So you can see the number just increases, yeah? And that makes sense because project time, okay, accumulation is going that way, yeah? And then they accumulate, yeah? And they're gonna going forward, the earliest start time, okay, for an activity starting at the node. It's just to pass the largest earliest finish time definition, okay? And that is for all of the activity ending that node. So here you have one node here. So if you look at it, this is where, okay, telling you activity B and A ends here at this node. Yeah? And this is the starting point of activity C, starting from this node past the largest earliest finish time. The same thing going on. This one, go there, and here. Another one, start from here and go there. This and this go towards that and end right here, past that. Another one is going to start. Now, we're going to go to backward. Okay, the other one is forward. So for backward, it's not earliest, it's latest finish time for an activity ending. Okay, add a note again. It's past the smallest, latest starting definition time. This is, you can cut it out. Okay, you can read it, so don't confuse your brain by reading. It will get you. All that you have to do is backward, largest finish, and then it's going to pass the smallest, latest. Yeah. So, and you can turn that into your own word like I do to get it. And so you can be able to see that. Okay, so here we're showing you the plant construction network diagram and with activities. So let's go from one, going to second and the third node right there, and we have no activity right here. We have two activities going on at this time. Okay, this can be weeks or months or days. Here they are not identifying what that is. Okay, so it's from the, I believe it's the same for construction, so you go with their time in weeks. Yeah, so 10, 12. So in order for this to go to here and then to here without path, okay, it's going to take about 10 weeks, but that's just 0. For you to go from 1 to 3, the same thing, it's going to take 12 weeks. Yeah, and then 3 weeks and do your activity C. 17 weeks for activity E. And these are your relationship between these activities. So anyway, if you know this is the network diagram for CPM and PERT for project management, you have learned something that's so important in management. Okay, everyone knows how to use this in management, project management. You will be doing. Okay, all right. Continue your plant construction network activity, ES and EF times. All right, then we're gonna go the same thing. We've got A and B, and then okay, that's demi. Here, see, automated mistake right there. That should be in dash line. So anyway, it should be like this, blah blah, and then blah blah. And then when you have to read all the time, then you can spot other people's mistake right away. And you will get to that kind of excellence, okay, in your life, because you have to, just by now, you know, oh, that's wrong. Authors, maybe it's not author's fault, maybe it's just a printing fault. So here's a C and then G and then E and F and then H and then I, okay, and these are your times going, yeah. So make sure you know the backwards and the forward, the earliest for forward, okay, latest for your backwards. You have to get that. So altogether, when you add everything up, you're gonna get 45 weeks. So you can see the largest right past your note, and you get 45 ending right here at note 8. So that's the end of your project, and we spent altogether 45. Okay, 45 weeks together. So here I'm gonna circle that so you can see, okay, the totals for each. All right. So here we have 38. So these are your total. Okay. These are your end. This is your start after a note. This is end before the note. Okay. And this, okay, end before the note. So that's your total project time right there. The same thing. Starting 32, ending 32, we're going to start with 32. Okay, so that's a 32 week. We're going to do the activity, okay, F, and we're going to spend 8 weeks. So therefore, a total of, at this step, we're spending 40 weeks. Okay, and we're going to start from the 40th, okay, week, and then we will do activity I. Okay, I'm going to spend 5 more weeks. So therefore, we ended up with 45 weeks total, right? Big T right there, total. Finish the project at note 8. Okay, so that's pretty easy to read it. So let's see on this side, we're going to do it again. So now you can see the same thing. Okay, we start here. We haven't spent any time, and we're going to spend 12 weeks in A. So therefore, we're going to end 12 weeks by the end of activity A before we start note 3. We do the same thing, we're going to spend 10 weeks. So we're going to end at 10 weeks at the end of activity B. We're going to start with 10 weeks, and we go demi, all right, PAP, spending no weeks, and then we're going to start activity, okay, C from note 3. So here altogether, you have 10, and then you have 12. You can start with 10 because you're already at week 12, okay? So this one is just start at week 10. And demi meaning like we're not continuing anything, we're not doing anymore, okay, right there. So only A is flowing all the way to week 12, right? So now from week 12, we're coming into here, and that is your 12th week, all right? And we are going to use it, yeah, and then we're going to use 3 more weeks, right, to finish our activity C. So now our total is 15, yeah, before the note, yeah. So now we're going to start again, all right, there we go again. We're going to start at 15 week, 3 activity. You do E, D, and then G, okay. E is going to take 17, D is going to take 23, and then G is going to take 12, right? So right here, you have all together, okay, add them up. So you have this and this, all right? So you add them up, all of it. So how do we end up with 27? You're going to add this and this for G activity. Okay, you start at the week 15, meaning like you have already spent your project 15 weeks. And then we're doing the activity G, and then it's going to take us 12 weeks. So by the end of activity G right here, our end point, okay, we are at 27th week. Yeah, you add 5, 6, 7, 1 and 1. Okay, when you add 1 and 1, you got 2. So 15 plus 12 is going to give you 27. The same thing you do 15 plus 23 right here is going to give you 38. 15 plus 17 is going to give you 32. Okay, now I have already explained that for you. So anyway, so that is your CPM and your PERT, PRT. Okay, it's not that hard to fill this up. Okay, you got your activity, all right, and then you have your start note, okay, and then your end note, and your end note is going to start again to another note, and they're all connected. Your relationship is your activity, which one you're going to do first, okay, and then you go by the time. So this can be, all right, if you go micro or nano, so those are right in the lab, happening in the petri dishes, some experiment in biochemistry or biology or chemistry. These are going to be 10 to the power negative 19 or whatever time, okay? Outside macro, we're in the macro world. So here is going to be your day, your week, okay, your month, or your year, okay? So now you know how to do this. All right. 811, this is completed plant construction. Network is nothing but this is your network diagram. So here we go, completed, right? We do the same thing. Okay, trace all of that, your A and then your B, and you will keep going, yeah. So here you're spending 10, yeah. So the end time is 10. And the difference between the other diagram and this diagram is we're showing a critical path. So now you have 2, look at that, for each activity. Are you going to go this way or are you going to go that way? Critical, again, is the longest path, right? Longest meaning we're doing the time estimate. So here, that's 10 weeks. And this is your critical path. It's going to take 12 weeks, the longest that you can go. See? Okay, this is fine, yeah. They're the same here, 40, 38, 35. at the end of the day is you got 45 the same thing. You have to, because that's what you have planned. Yeah. So this is what you have planned. See, here is my laser coming back again. So here, that's your end time. So you have critical path. It's the longest path, right? Here 12, 12, 12, longest path. Going that way. Okay. All of that. So you will see again, where's my point? Oh, here. So look at this. This is your critical path. Okay, I'm gonna show this to you. Why? Because you spend 12 weeks. Here you spend only 10 weeks. Yeah, for activity B. Now let's take a look at activity A. So here, and then here, it's the same thing. Yeah, we're spending 12. So the critical path is the longest again, 12. Then we'll get into another one right here for dummy. Okay, critical path is this one, 12, longest one. Then we're gonna come here to the next one. So here 12 and 3, activity C, critical path. Here's the same, so right, 15 weeks, critical path, and then here we go again. So anyway, so you know how to read it by now. Okay, next table. So project analysis, forward and backward pass. So here we're reviewing our notes, our time. So ES, EF, LS, and then LF. Okay, these are all your time that you can be able to see the completion. Okay, we go all the way. When you look at it here, I'm gonna circle that for you. That's the end. Okay. Yeah. So here we're dealing with the critical path. All right. Binding means just connected activities. And we're checking the forward and backward passes, right? And this is just a slack. You know, where are you going to get slack? Why? Because of the critical path. So here your star right there. The star is right here, okay? So critical path of binding activity. So identify here. So if you take a look at it, you're going to see in C, okay? The same thing with A, it was right there. It was, remember, like connected 1 all the way to 3, and then it's going this direction, yeah? And then you have your 12, right? 12 weeks right there. And then we're going to start with 0, and then you ended up at 12 weeks, yeah? And that's your activity A. And relationship between 1 and 2 notes right there, yeah? So here you already know that's your time, 12 weeks. So I'm going to erase this for you. So there we go. So now you can read how to do it. So 1, 2, 3, yeah, 12. It's right there. 0, okay. And here is your 12, yeah. And then that's your 0 starting, okay. And this is your LF is your 12. So which is the same thing. So I'm gonna write it back down here for you, like that. So if you try to remember, oh, what's ES? I don't know. So that's earliest, yeah. This is latest, yeah. And this is your start, okay. So you have earliest start, earliest. This is your finish, okay, for F. So here is your start. So you can see here, and we call this finish is your end, yeah. So earlier start, earliest finish. So you've got 0 as earliest start. Earliest finish after 12 weeks, that's 12. This is your latest, okay? And that's your start, latest start, also 0. And then that's your latest finish is going to be 12, okay, in this case. So that's how we determine, again, critical path. and you're gonna choose the longest one. Okay. Alright, next one is your PERT network probability analysis. So we're starting CPNs, and then now we're going to touch a little bit on PERT. So managers never have the luxury of precise fixed time estimate. We don't have that, okay? Our guesses are our guesses, yeah? Estimate is estimate. So activity and project time and variance computations. So here the PERT probabilistic method extracts 3 time estimates for each activity. So every activity that you have, we're gonna get 3 time estimates. So time estimate is just a big word. It's just telling you that you're gonna guess 3 times. Okay. Now managers experience in their areas of responsibility can think through accurate values for these things. So again, we're gonna go back to our optimistic, so which is your shortest time, yeah, to complete an activity, and you have most likely, which is now we're giving coded it, M required to complete an activity, and we have B with bad. Well, pessimistic is your negative thing, so that's your longest, right? Negative is because you're taking a long time to complete a project, so that's why we call it pessimistic, yeah? Longest or worst case scenario. So time for an activity completion. Shortest is really good, and we call it optimistic, okay? Positive things, because you can finish the project in a shortest time, yeah? So that's how we evaluate the project time. Okay, so for CPM, we were concentrating on the critical path, which is your longest path. And even though we evaluate the longest path, our goal is to finish in the shortest time within the shortest time frame as possible. So that's why we calculate what's the longest time, so we can complete before that. So anyway, for beta distributed activity time, for which 3 time estimates, so that's your 3 time guesses, have been elicited, okay, its average or mean value is calculated by using this formula. So that's your T and that's your A, okay, and then this is your M, and then that's your B divided by 6. So now we're going to use coded one. Here, that's your, every time you see A in this case, we code A for optimistic shortest time to complete an activity. Then when you look at the M, that's your most likely time required to complete an activity. And this is your B, which is your pessimistic, your longest time, okay, for an activity, and that's your time. So every time you see this, what I do, that's shortest, that's longest, okay, that's the standard. So that's how I do it. You can do whatever in whichever way is good for you, convenient for you. Okay, so let's get into calculation. So I found out about you guys. You guys are good at writing, right? You should be, you ought to be, and calculation is kind of okay. So we're gonna go this little by little again, yeah. So here we have time. So this is how you calculate. So when you take a look, where's my pencil? So when you take a look at this, well, we're gonna relate this to right here, yeah. So this is your T, okay? How do we get this time? We're going to calculate by using this formula. So your 9 is going to go right in here, yeah? And then your 12 is going to go right in here. And then your B, which is your 15 for activity A, so I'm going to put a line right here. Okay, so all that you're doing right here is your T. Okay, we're going to start calculating that. You can call your formula. Your formula is put the, okay, shortest one first. So we're going to put your shortest one. Okay, and this is what I do. And then I'm going to put my longest one. So that's my longest one. You don't even have to remember anything. Just by looking at it, see? 15 is greater than 9, 16 is greater than 8, 0, that's a demi, 5 greater than 1, 30 greater than 20. This will always be greater than that. So since when you scan it, you already know B, O, all of that is greater than, so therefore you know this is the longest, okay? And that is the shortest. mean, medium, you can take it. We call that just like standard. Okay, everything in the middle is your standard. So now we're gonna multiply 4, okay, and then time, okay, and then your m is in this case is 12. Yeah, if you use a calculator, don't forget this bracket. Okay, it's gonna mess you up. So make sure you calculate this first and then calculate the rest of them, add it up. So and then it's a formula, so please divide that by 6. So when you do that, you're gonna get your final answer 12. Yeah, and you should be able to do all the lines right down there. So practice that, please. Okay, and then I'm gonna erase this. Alright, so now we're gonna get into the second one right here. So in the activity time variance, so variance again your v, okay, that's your sigma to the power 2. Okay, variance is always standard deviation the whole square. Yeah, sometimes you're gonna see like v the whole square. It's just telling you this is your sample and that's your population. It's the same thing. So anyway, here now we're going to get into the activity time variance. How we're going to calculate that? We're going to use this, all right, formula. So when you use this formula again, we're going to call B is your longest minus shortest. Okay, longest minus shortest. So that's every time you look at it, you know that the longest is right there, the shortest is right there. Since you are subtracting, okay, your shortest one out of the longest one, you're going to be getting this. Okay, we always do that, and that is your difference between the 2 points. Yeah, we always do that. Okay, and usually that's we call the average anyway, but then in this case it's your shortest. So you should be able to see the formula now every time in whatever we're doing. Okay, so and then it's please divide it by 36. So that's just what calculating our variance anyway. Variance meaning how varied they are, how different from each other, your deviation, your variance. Okay, that's what we're calculating. Every time you have to deal with something that is varying or deviating, you are trying to find the distance in between them. Okay, and this is showing you how are they varying, because A is definitely not equal to B. Okay, so you can say that. Why? Because there's a distance in between them. All right, there's a gap in between them. So what is that variance? What is this? Okay, and you can find that. So variance is kind of like a rate right there. And you square this. All right, difference between A and B. In this case, we're dealing with the time, all right? Then square it divided by 36, and you'll get the variance. Yeah. All right, so the next one, let's go in here. So if I ask you, oh, please calculate variance and give you this table, you're gonna use that, you're gonna use this, okay, minus that, and square it divided by 36. Now, project time for final exam, I'm going to give you the formula sheet, but you gotta know which formula is what. Alright, especially one student who can't remember the formula. I will give you the sheet, but you have to know which one is what. Okay, so project time variance V, okay, and that's your sigma squared. Alright, sigma squared. Coming here, V is equal to sigma squared. And then we're going to calculate that, alright, and you will get this. Okay, so here is like you can put any one of them, right? So this is just an example. So 248, I don't know which data set this person is using. Let me take a look at it. Okay, so I checked it, and yes, this is what belongs to the table 84. So anyway, so what we do is you are going to add them, all of this, all of that, okay? So here you can see the division, yeah? Division is like this. So that's just a 36, so we're calculating this one for each row right there, yeah? So this is your variance right here, each one of them in this column right there. We calculated it. So now for critical path activity, your ending is total of 45 weeks anyway. So the project time variance, we're gonna get our total, which is you add the whole thing up right there, you know. So we get 248. I believe this is it. Okay, so if you add everything up, so this is 100, 200. Okay, that's already 40. So here is a 300 because that's 60. Okay, and then you're gonna get another 100, and the rest of them is gonna give you 48. Yeah, so that's you get 248 divided by 36. So you get 6.89, and that is your project time. The whole thing. The whole thing. Okay. Each row, each activity, you got that. Alright? Alright, so these are all your PERT, time estimate calculation. Again, don't forget this is PERT, not CPM. Alright, the standard deviation is sigma. So we are getting the square root of the variance. So the variance is sigma squared. Okay, so therefore the square root of the sigma squared is sigma, so it's standard deviation. So that's what we're doing here. So when you take a look at it, so let's go over there. I'm going to erase this on the board. Alright, so now you can see right here, right, 6.88, and you square root it, and you're going to get 2.62466, and then you round it up to 3, alright, decimal, so that's your 4 significant figure. You're going to get 2.626 weeks. So the average project time, again, total 45 minutes, or sorry, 45 weeks. So anyway, so you have 45 weeks, that's your average project time right here. So you can see right here under the table. Alright, so we're going to complete the report by saying we have the standard deviation that is plus or minus 2.626 weeks. Yeah, the longest is going to be 45 plus 2.6, so therefore that's 3 weeks more. So you have 48. Yeah, and then so let me draw that up for you so you can see. Alright, this is our estimate 45, and then we have our tolerances right there. So your range is going to be, alright, so 2. So if you minus 3 out of it, you're going to get 42. And then you're going to get the maximum is going to be 48. Okay, because 2.6, when you round it, you get 3. Okay, so plus or minus 3 weeks, okay, is your standard deviation. So I'm going to put a little S right there. So that's your project estimate. Yeah, normally estimated, okay, to finish this project 45 weeks, but we can finish as early as 42 weeks if everything's going smooth. And if something's going wrong, whatever, so the longest path, critical path, is going to be 48 weeks. Okay, but then this is our CPA anyway, so CPC, so that's our critical path. This is just showing the standard with deviation. You can go all the way to 48. We don't want that because it costs more money. Yeah, so if you can save like 3 weeks, yeah, minus 3 weeks out of our average right there, you will save a lot of money. Yeah, when you deal with a big project with so many people that you have to pay 3 weeks. Yeah, some people you have to pay like 2,000 or 5,000, 6,000, some in 100 ranges. You can save that money by pushing your projects. All right, so a good project manager. So when we say project managing is playing with this time estimate, right? Saving the time, we call it time is money, time is money, time is money, and you don't understand. But now you understand as industrial technologist, when you have to estimate the time in your project, that's what you're gonna do, okay? And this is how you save money, okay? Billions of money if you get big a company. Okay, if you get medium size, so you'll be saving thousands of money, yeah? Anyway, so next one. So project time probability, assessment time probability. Probability is important because you are so what are you doing? You are calculating, okay, and thinking, considering 360-degree around the scenario, okay? So you think about every possible event, right, that can happen. We call it 360 around thinking. So like brainstorming, okay, and come up with every possibility that can happen. And we call that mathematically is probability. And again, for mathematics, we represent 0 all the way to 1. All right, 0 all the way to 1. And don't forget the infinity, okay? From here to 1, you already know the number system. You have already studied that. They are actually point, yeah? So each point is not connected. None of them is connected in this line, even though we draw with a straight line. So it's going like this, yeah? So this is infinity because you have, if you go 1 point right there, let's say this is a 1 division right there, going from 0 to 1, you have 0.1 and then you have a gazillion of decimal you can go, right, all the way to infinity. So none of the point, and that's why we call it point. Okay? We're imagining and we're connecting, and we can draw, right here with our level in life, right? Because we're a human species, and this is how we understand a line. But mathematically, they're all just points, right? Series, call it series of points. But then none of them are connected. Each one has an infinity right there. Yeah. Plus and minus infinity right there. So anyway, so these are it's gonna blow your mind if you sit down and think about it. So anyway, here we come back to the project time, and we're gonna deal with probability analysis, which is your assessment. We're gonna evaluate. All right. So project time T, we call that T distribution, is visualized as a normally distributed bell-shaped curve. So those of you who are taking stat, make sure you pay attention to T distribution. If you have ambition to continue to study and go from undergrad to graduate school, all right, you have to deal with this in your research, okay, your thesis and master's and dissertation and PhD. So it's visualized as a normally distributed bell-shaped curve. So project time, we call it T distribution. So here is my pen. So this is your normal, all right, distributed bell-shaped curve. So we call it normally distributed because most of the data, okay, turn out to be this kind of curve. Okay, they didn't turn out to be like this, or they didn't turn out to be like that. Okay, it's always come this way. Most of the data set, okay, from most of the research data, when you draw it, it's always come out like this and showing you the average is this, and then screw, okay, on the left and on the right. Okay, screw meaning like these are all your outliers. Sometimes you're going to get the data right over there, and that's your outliers. Yeah, right. These are majority of the data found under the middle part of the bell-shaped curve, and we call that again T distribution for our project time. Okay, factors right there, project time, and we're going to represent this way. So a bell-shaped curve, and here in this case we give it T is equal to 45 at midpoint, right? We already get that. So remember our standard deviation, right? This side and that side, and we've got 45 plus 3, so which is this guy right there, and we estimated about, so this is about 48, about 42, okay, on this side. Okay, so you have minus side and then you have plus side. On that way we call that the T distribution. Okay, so anyway, you get it. So I'm gonna erase this, blah blah blah, and we're gonna continue. So here your sigma, where's my pointer? Here's your sigma is a 2.625. Alright, annotated as a distance from the center line. So this is your center line. This, okay, is your standard deviation. Saying it is deviated from the midpoint that much. Okay, that much, that amount. And from the center line to the points of inflection above and below the mean. So this is point of inflection. That's above and below the mean. So this is above and that is below. The mean is right there in the middle. Okay. So let's get into some calculations about your probability review here. Okay, now you're given a scenario. So suppose a less than 48-week goal was important to the company. So what is the probability of meeting or exceeding, okay, that goal? That is, so you have like a P and then T, okay? That's just a formal way of writing, okay? And here you already know what T is, yeah, right? We call this the average time for your project to complete. So here is the maximum weeks that we got it, like 48 weeks, and it's got to be equal to that because this is your maximum, and it's got to be lower than that, okay? Because our standard deviation, right? The lowest specification that we're looking at is 42, yeah, approximately, and then we have average is 48, all right, and then we have 48 is our maximum, yeah. So this is the longest, and then we have our shortest 42, longest 48, medium 45, yeah. So that's what it's telling you, and this is your probability, okay. And the question is asking, how much is that? I want to know. How much is the probability of the total average time, okay, is going to be less than or equal to 48 weeks? Meaning like, right, how many percentage, okay, so of the time we will be spending longest, okay, longest time for this project. So you have to know that probability, okay, so let's see how to calculate that. So here, a normal table calculation from your stat. So we're going to recall, right? That's your z for your normal distribution. So we always calculate this way, our mean, okay? And you're going to minus that. So this is our maximum, which is your 48. And this is our mean, so minus 48. And your standard deviation, we have already calculated, okay, around 3. So take it out, and you got 3 divided by 2.625. Okay, that's about 3 anyway, so you're going to get like 1.14, okay, standard deviations. So that's our z at 48, okay, z value. Now we're going to take our z, okay, from normal distribution table, go to the table. So that's usually given to you. If it's not given to you, you can Google it and it will come out. Okay, I'll give you one table right there that we can get. If you have a textbook, it's always in the back of your textbook, okay, back pages in the index, and you can find the normal distribution table. Go there and then look for 1.14 because we got z 1.14. So when you go there, you're gonna get 0.37286, and that's, okay, is going to be your area, all right? So the area under this z number is that, so that's about 37.29%. So here the area under the curve for completing the project in 45 weeks is 0.50. So we already look for 48. We're gonna do the same thing at 45, yeah, and you'll be getting like, all right, you will get 0.50. Why? Because that comes from your graph. You cannot calculate like this, okay? So this one is, I'm gonna draw it back to you so you remember like this way, yeah. And then you have your average right there, and we know that the average is 45, yeah, and that is at 50%, yeah, because you're dividing the curve, and this are your area, right? Area. So here, that's your 50%. Okay, that's 50%. So it comes from there automatically. So anyway, I'm gonna come back to here. So now we're getting into here. So therefore, so go back to our calculation. We're gonna add that to area. So you have 37 and you have 50. So if you draw this curve again, we have at median of 50% right there, and then you're gonna add 30 more, 37.286. So that's all. This about, let's say 30, but from here to here is, okay, 50. So therefore I'm gonna cut it right here. So you're gonna add that, okay. So you will get this, okay. So that's the 87.286%. So that's, we get 87%, okay, of that project is going to complete in 48 weeks. So it's not really good project, right? Because it's leaning towards the longest time. So here I have about 38%. So anyway, this is about 8%. So you got 87% leaning towards 48 weeks. Yeah. So it's pretty, it will be hard, okay, for you to get 100 minus, right, 87% to complete it in 42 weeks, right? So it's pretty intense. So anyway, so that's how you calculate it. So let's go to the next one. So here's additional comments per network. And analysis, just like we're looking into the time estimates and all that. So give a realistic complex project, and it can have more than one critical path. So you have more than one longest path. So you can, add your time estimates right here. So you have 4 months, 3 months. So, and then you can find the longest path, right? That's how, and then you're going to give all the notes right in there in the path by using these letters right there. So all the paths will have the same estimated project time, but variances usually be different on each critical path. So the critical path of most concern will be the one with the greatest variance, right? So again, this you need to calculate in order for you to be able to see it. Your brain won't get it right now, so you just have to go slow and take it in slowly. So the critical path of most concern will be the one with the greatest variance. Okay, though we have to see the variance number in order for us to be able to see the critical path. All right, so let's go down again. Okay, so time now we're coming into cost trade-offs. So the manager can assess time, cost trade-offs by analyzing how much additional cost is incurred. If the project is reduced to less than the original time shown by the network computation. So here we're going to start playing with the time and cost. So after studying the time estimates, we're going to put in the cost factor. So activity time estimates are often given in terms of normal and minimum times with related costs, so that the time cost comparisons are possible. We're just telling that we can be able to compare these two, right? If we have this activity time estimates in terms of normal and minimum times, yeah. Again, time is money, yeah. So therefore you have to weight between the two factors in order to make your project successful. Again, on computer software, we have then exist, that allows the analyst simply to input the initial project activity table, or precedence, and normal minimum activity times and related costs. So here you're considering their trade-offs. So therefore you have to analyze your time, and then you're going to analyze your cost, and then you're going to come up with the best, the best possible outcomes for your project. All right, your CPM crash analysis. So here, CPM crash. Now we are looking at the time cost trade-off, right? So the table is a little bit different now. So when you look at the table 8.5, you can see the 8 activity. Why is it 8? Because you just count right here. I'm going to see the 1, 2, 3, 4, 5, 6, 7, and an 8. And remember, like they're coded. So therefore you have description for each activity, what they are, okay? And we're studying the construction anyway of your manufacturing plant. So remember, you will go back all the way to the first table, okay, to understand what we're doing right here. Then shows you have 8 right here, okay, and then we have normal minimum time. It's right here, yeah, normal minimum time for activity, normal minimum time, and then you have, we're studying cost, okay, so here we have normal minimum cost right there, yeah, so we have time factor there, and we have cost factor there, and we're analyzing our normal and then minimum, our normal and then minimum. Okay. All right, so this figure is 813, all right, 8. So 813 has a series of pictures and diagrams. It's going to show you, again, your network diagram for this project. So the very first one is, you can see the cost, right? So this is just an estimate, all right, we're guessing. So here we have T 49 weeks. And then we estimate we're going to use about 54,000, that's your K. 54K in it and can be calculated. Okay, you can estimate this one, all right, by doing some calculation. So what are we gonna do? You're gonna add, all right, activity cost, normal column, all right, and you already know your table that's coming in like 1,000. If you look at the previous slide, okay, I can go back right now, and you can see that, and a critical path follows the activity. We already know the longest path, all right, that's your longest. It's gonna go like this way, and then that way, and then you go there, and then you go here, all right, that's your longest path. So this picture is a little bit like vague right there. So if you pay attention, you can see, let's see how they bold these critical lines, all right, critical path lines right there. So let's see how are we going to calculate. So 49 weeks, all right, that's a 1 week over the 48 one. Anyway, so that's going to cost you 54,000. So now we're going to play between time and cost. So here I want to show you your activity, and this is in thousand. All right, so when you look at it here, you're gonna see that's 9,000, that's 15,000, 13,000, so on. So here that's 6,000, and this one is 12,000. Okay, so all the facility system plans, all right, and manufacturing corporation company, all of that go by big money. Yeah, usually hundreds, thousands. All right, and then you're gonna have all kinds of zeros right there. So anyway, you're playing with big money, so you have to pay attention to your job, right? And it's a serious job. You'll be taking incredible amount of responsibility, right? So anyway, so let's come back here, and that's all I want to show you. And here, these are your cost week. Okay, so if you pay attention here, we have activity there. That just intermediate the predecessors showing like, well, which one is come where. Okay, and then here is your time, and pay attention to the units right there. So the units right here is weeks. So going normal and then going minimum, and then we have activity cost in thousand. All right, and then we have our cost per week. Okay, this is just telling you that we will be spending $3,000 per week for activity A. We're going to be spending $2,000 right per week for activity B. Okay, and we will be spending $1,000 for activity C. Okay, all right, so I think you got it. And this is our estimate. We're estimating for cost. We're going minimum. Why is it minimum? It's because it's going to cost you smaller amount of money, right? So the minimum cost is our aim, our goal to finish our project. We want to spend as as less as possible. And the same thing, our estimate time. Okay, our goal is, all right, to finish the project as soon as possible. So therefore, that's why you see our goal minimum here, normal, and then we're doing our comparison right there, and then play with our time and cost and calculate our trade-offs right there. Okay, so here I'm gonna erase this, and then let's go into it. So now you understand all these columns in your table. So let's move on. Okay, here. So 813. All right, where are we right now? So we'll go back to our A, okay? So here's our critical path is going this way, B, E, and then F, and then G, okay? And then you have to calculate, okay, 54,000. How did we come to that? We're gonna look at the time, okay? Your B, all right, we spend 13 there, yeah? And then your E, you spend this, all right, 8 and 7 weeks, and F 8 and 7 weeks right there. Okay, and then you have your 2019 right there. So what you do is you're gonna multiply, all right, these weeks with your per, all right, per week rate, all right, and then multiply, let's say for B, as far as I remember, it was like $2,000, right? So $2,000 and then you're spending 13 or 10 weeks, so multiply with that week. And then you do the same thing. So for E is like, let me take a look at it, 1, 2, 3, 4. So you're spending about $4,000. $4,000 times your total weeks in E. So for F, another $4,000 per week. So times your total weeks in F. And then for G, you're spending $6,000, okay, per week. So you're gonna time with your total weeks right there and then add them up, and you're gonna come to $54,000. So that's how we calculate, okay, from this network diagram. So how do we calculate the cost benefit by reducing the week? So for instance, let's say I'm going to save 1 week. So instead of finishing the project at 49th week, why not we reduce 1 week and save some money? So how much are we going to save? So that's how we calculate, and that's why you have in the table, the cost for each week, for each activity. Okay, so you can eliminate some of the activities and some of the weeks, and then calculate that cost. Alright, the next one, we're going to reduce 1 week. Okay, let's reduce 1 week and see how much are we going to save. So 49 weeks we spent, right, $54,000. Yeah, so now we're going to reduce 48 weeks. If we do, what is going to be our cost? You know, our critical path is B, and then E, and then F, and then G. So now we're doing the trade-off. Okay, your trade-off is I am going to reduce the work, and it will cost me more, but I can save other stuff. Okay, the project will go up 56, but you will be saving, what is the savings? And you're not saving this for a project, okay? You're saving the time. So the time comes with your wages for your employees, and that's saving 1 week, not paying all of your employees right there in the project, okay, is your saving. And we can trade it off, right? That time saving 1 week with this cost, because this cost, I'm going to highlight this for you, is less than you paying all of your employee in your project for 1 week, okay? And this is how we do it. Yeah, even if you might be spending like $54,000, I remember, for 49 weeks, right? So $54,000. So that's only gave you, a saving of $2,000 right there, right? If you go for the 49 weeks, one employee being on that project will cost you, for 1 week, it's going to cost you $1,000 to $3,000, depends on their rank. Yes. So even the lowest employee, let's say labor, right, is going with the $10 to $20 an hour. So they will be making, if it's going at 40 hours overtime. Think about that. Yes. So saving 1 week for paying all that employee on that project saves tremendously more than you save $2,000, okay, for your project. So this is how you calculate in Perth. So anyway, you got the idea right now. Okay, here we go again. So let's go down. Oh yes, I have to mention how we come to the $2,000. So the result of this analysis right there. Okay, so what do we do? How do we reduce 1 week? So here I'm going to highlight that for you. So we're going to reduce, okay, hit on activity B. So this guy right there. Yeah. So instead of 12 weeks, okay, sorry, instead of 13 weeks, okay, this is just showing you the final version of that. So you have to go back to the 48 weeks, all right, picture. So in the 49 weeks picture diagram, which is in 813A, I believe. So in that case, you were spending 13 weeks for B. Okay, now we're going to spend 12 weeks for B. So we're going down 1 week right there. So we save activity B. The rest of them are the same, yeah? So therefore 1 week saving on activity B, all right, is going to increase the project cost from 54 to 56 because 1 week, okay, is going to cost $2,000, yeah? So $2,000. So therefore, cost 56,000 can be calculated by 54,000 and then plus $2,000 of B cost per week. Okay, so now you're thinking, oh, I took off, all right, 1 week from activity B. Why is my cost increasing? That's because you're spending that $2,000, okay, to the employees, okay, to the employees who are doing the project within 12 weeks, okay. So what you're doing is you're giving that money, all right, to the employees and then push them, all right. So that go into what I would say like bonus or okay award, some form of okay incentive, and then we're gonna give that. Hey, I'm gonna give you all right $200 more, and you're gonna complete instead of 13 weeks. You're gonna do it, okay? Finish your activity B within 12 weeks. I'm gonna give you incentive, okay? So and so amount to your project. So let's say this project is done by 4 people, and then you're giving $500 more, all right, to reduce that. Yeah, so they're getting $500, all right, more in addition to their salary for that. Okay, if you go by bi-weekly or by hour, whatever that is. But this is what they get by saving 1 week. So they're like, oh yeah, okay, I'll do that. Yeah. So I don't have to, spend 13 weeks for doing this thing. I can just finish it and get it over in 12 weeks. I'm going to push that activity B or everything done within 12 weeks instead of 13 weeks cutoff time. So you're giving the incentive $500, and therefore it increased for 54,000, all right, 54,000 to 56,000. But what are you saving? You're saving time, all right, and saving 1 week of time again, all right. You save the salary with paying them benefits, all right, and then you are saving everything that these employees are using, all right. Resources are being saved, and then if this is we're in the maintenance right here, so you get customer appreciation, okay, which is your internal customer for maintenance system because you're dealing with your upper management and your stakeholders, okay. They want it done, they want the production back up. Let's say if you're in the facility manufacturing plant, you get this system back up in a less amount of time, right? So we spend $2,000 to trade off that amount of benefit, okay. So 1 week, okay, you maintain and you get the system back up, the production, okay, if you think about the Fortune 500, all right, corporation manufacturing, let's say a product will earn the company billions of dollars. And this is how you do your project, okay? So $2,000 increase in the project, cutting out 1 week is going to give the company tremendous amount of benefit. So when you become a manager, you do not manage whatever. You have to use, all right, again, go back to application of your knowledge and tools. This is how you decide. Okay, you can say like, hey, can we finish and just go to meeting with a coffee and sit down and say blah blah blah. You don't do that. Okay, real good managers, they're calculating this, all right. And there are people who just don't know what's going on. Also, there are people who are actually systematically studying the project and pushing everybody in the right direction. They're going to say, hey, why don't we do it within 12 weeks? and they're not going to tell you anything about how much of the profit the company is going to be making at all to you. All right, they're going to just tell you two things. One is, I'm going to pay you this and this more to push the project to reduce 1 week. Can you do that? And you're going to say, you're going to talk with your crew, talk with your team. Oh yeah, of course we can do it. We're going to take, $500 incentive and push the project to finish 1 week less than what we're supposed to be doing. And you know nothing about, okay, how much the company is saving from their business within that 1 week. Okay, so it's all connected. Stakeholder meaning like connected to stock. Okay, stock market, everything is time and money. All right, so make sure you start to think in a big way and understand these zeros. Okay, in the back, and make sure you use the correct method and calculate the best you can to play with this time and cost trade-off. So we're done with 48 weeks. So let's go another one. Come back here. So here we're gonna show, where's my pointer again? So here B, we're targeting B, reduce 1 week. So cost per week is gonna cost you $2,000, yeah? And we're gonna give that $2,000 to the people on that project. And then we're gonna save 1 week. Yeah, with 1 week, you will be getting the company, saving incredible amounts of money. Yeah, because the production, because we're in the maintenance project again, your system go back up, your equipment is running now instead of not running. Yeah, so now you're gonna go back to the regular production and give you that production, benefit money for the company. Yep. Now let's go to the next one. Let me erase this for you right there. We'll do the same thing again. So give you some more example. So go down again. Next one, we're gonna reduce. So to produce project time by 1 week, the reduction must be made along the critical path. We already know that. So because we are cracking this critical path, longest one down. Yeah. So activity B here, reduce 12 weeks, from 13 weeks, reiterating the same thing. So the result of this analysis is shown right here, and then we got now 56,000. Now let's go next one. 47, we're going to reduce again. This time we're going to hit. Let's take a look at it. So which one are we going to hit? We're going to hit again, right? B and then F, activities. Yeah. So this time we will be adding $4,000, yeah, to your previous 56. So that's 56,000 for 48 weeks. We're going to reduce this time activity F. Activity F is costing you $4,000 per week. So edit, and you're going to get 6,000. So here, check. So this is your activity F right there. So here, this is your line. So here we go, $4,000 per week is causing to reduce, right? 1 week is going to cost, $4,000 to push the project 1 week, down. So you're going to add that dollar amount to your previous 48 weeks, and now we got 47, yeah, right there. And here is your activity F, yeah, and we reduce 1 week, at $4,000, right? First we reduce B, 13 from 13 to 12. We reduce F from 8 to 7, yeah. B cost 2,000. You added already. F is going to cost $4,000, and you are added already. So now our project is going to cost us $60,000, right? But we did it 47 weeks instead of 49. That's a saving of 2 weeks. And with that, again, company is now using your system, which is now repaired, and maintained. So coming off from your maintenance project, and this is the dollar amount your company is saving. Yeah, making out of that 2 weeks. So if your system is down for the next 2 weeks, company is losing that amount of money. And if your system is so critical, they will be feeling so much pain right there. Yeah, they're going to tell you reduce, get the system back up, get the system back up. I want it now. Yeah, so then you reduce it. That's the dollar amount you are making out of that saving 2 weeks, and you spend only $4, $5, $6,000 in total for incentive to push the project 2 weeks. All right, down. Now I'm going to erase this for you. Now let's go next one. We'll go again, blah, 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 blah. All right, next one. Next one is now we're going to do A and B activities. Okay, we're going to reduce both of them each 1 week. So B now is down from 12 to 11. A is now down, okay, 10 to 9 or 9 to 8. And then we're going to add their per week cost. So we have 3,000 and 2,000 is B and 3,000 is A. So together that's $5,000. You add it to 60, so you're gonna get 65,000 right now spending. Yeah, but you have saved. Yeah, we have saved now 3 weeks. All right, 3 weeks. That's billions of dollars, by the way. If you're producing toothpaste, oh my God, the toothpaste tycoon from China earned a lot of money in 1 week. Yeah. So if you think about eraser, pencils, pens, Sharpie pens, so these are all the industry that you're thinking about, your door knob, your lamp, your light bulb, okay? So everything that you're using, everything you have, okay, coming out from manufacturing, and they are supplying, all right, all of that. So your production facility, your maintenance gotta be so perfect. Okay, you can't just keep the system down and maintaining forever right there. You can do that. Even for 48 weeks, that's a big system we're dealing with. Yeah, maintenance project. So this is when you look at the 46 week, you know that you're dealing with a big system. You have to go right up. So therefore 3 weeks is going to give you a lot of savings, going with millions and billions of dollars right there. And you spend, right? We started off from 54. Okay, you spend, so 65 minus 54. That's all you spend, all right? In order to trade billions of dollars savings in 3 weeks. Okay, so yeah, we're gonna do that. Yeah. So here we go again. There we go. Let's go back here. Go back to our table. And now we are hitting A. So that's 3,000. And then we're hitting B again 1 more week. So that's 2,000. Okay. Down to 3 weeks. So now you can see that. So I'm gonna go down again here. Next one. So let's see what are we going to do again. So here I just trying to tell you how we calculated it. So in order for us to get 65, we add $3,000 and $2,000 because we're hitting both activities A and B and reduce 1 week for each activity. So you add, okay, 5,000 to 60,000 and reduce, all right, 1 more week. So we're down to 46 from last time we reduced. So here we go. We're gonna cut 1 more week. So now down to 45. Yeah, we started out with 49 weeks. So look at that. So that's 4 weeks. Okay, a month. A month is a lot. Within a month, you have a lot going on in a company. So that's a lot of saving. Again, we are now spending 70 to pushing this project done. Okay, maintenance project done. So now you have this is we started out with 54. So let's take a look at, right, how much you spend. So this is 6, yeah, that is 6. So you spend 16,000, yeah. 16,000 is nothing if you compare 1 month of a production in a big manufacturing plant is going to give you millions and billions of dollars, but you spend only 16,000 to finish your maintenance, all right, project. So to get your system back up or whatever equipment you're maintaining back up. And that's how we do the trade-off. Okay, and this is what you have to do when you become a industrial engineer or industrial, all right, technologist. Don't go with the flow. You go with the data, and you're gonna make decision by sticking to your theories, your methods, your tools, and your calculation, systematic calculation, and then make the decision. All right. And if you say that I don't know how to do because nobody is teaching me the real world experience, that's that's your duty. Okay, that's what you have to do, not the professor job. Professors are we just showing you this is how we calculate, and the real life is in you. Okay, you are the real life. You have to use this. As long as you're not using this, your decision is going to be just emotionally based, and it will be biased. You will have prejudice, and you will have discrimination right in there in your decision, and you will be making the decision with go with the flow thing. Okay, and over time it's going to get to you. So every project, it doesn't matter a small project or a big project, you will calculate systematically. Okay, and you gotta know what's the cost, what's my trade-off, what's my time, and then am I going to do this or am I not going to do this? Are we okay with this? Ask your team, okay? Everybody said, okay, we're going to get this incentive, we're going to get the pay raise, and we're going to make this done. Okay, they don't really know how much the company is earning. You know, and you have to know, all right? So make sure, don't complain, oh, the university doesn't teach me anything about it. That's a stupid, comment you have ever made. It's just like incriminating yourself by saying, I didn't do anything, I didn't study, I don't know how to apply, okay? And you have to learn that by yourself, all right? And I would take all the hatred if you want to curse me or whatever. You can do that right now. But when you get into the real world, you're going to understand, okay, what all the professor told you will come true. So start doing that, okay, from now on. And you have already passed maybe 20, whatever, okay, you're getting into going forward from 20 years old to 25, whatever, and try to make a habit of using scientific methods, technique, tools in your management. Don't go with just a superficial, all right, what am I saying? I don't know how to say it, like a butter up, all right? We call it a butter up in your language, people. That doesn't work like that, okay? You have to know what you're doing. Some people, some managers just go being nice and good and talking, do nothing, all right? They don't even know how to calculate. They don't even have the textbook or anything at all. They don't even go sit down and use the analysis, software, anything at all. They don't even know how to use any kind of calculation per or CPM. They're just going with the flow and then say nice things and good things that everybody want to hear. Don't do that, okay? Because over time, what you do always appear over time, and people will know, oh, this guy is just a joke. He doesn't really know. Okay, so try to apply what you have learned, your theory, your concept, your method. These are so powerful if you know how to use it. Okay, if you know how to use it, so make sure you start to use it. Calculate. Don't be lazy to do your assignments. Start from now, today. Okay, do that. All right, so let's go into the next one. The same thing we're showing you, and you're going to play with the activity. You're going to calculate the cost, and then every week that you're reducing, you're adding the cost to your project. Okay, but then those costs is totally, you can compare to the benefits and the savings that you will be making by reducing these weeks. So keep here 70. How do we get this? Okay, we're gonna do the same way by reducing, get the per week cost, and then add to that. All right, for the former week cost. So that's how you calculate your per. Okay, so now let's continue with the realistic complex. So this is realistic, it's very complex. Real life is complex. Why? Because they do not follow standards. They do not care for theoretical concept. They just do whatever they want. The word is whatever they want, and they don't care. And there you are, right in the middle of it. And you call it realistic and complex. What am I going to do? The same thing. You stick to what you learn, okay, from your education, and play with these methods that other people don't know. Okay, you have the power in your hand. Use it. So here, table 8.6 shows an activity table, right? There's a very large, okay, project example. So here, when you look at it, we have like a 24 activities, it's very complex, yeah? And you have like 8 all the way to 8, this is X right there, okay? So that's a lot of, okay, a lot of activities that you have to calculate. So this is a big money saving, okay, project right there for you. So this, in this example, they call it like a BIGEX or whatever, okay, big X or whatever. So anyway, so this is activity table, and you already know, okay, that's your shortest, that's your longest, and then this is your most likely standard time. Now let's keep going. Don't forget your A and B and the formula, okay? So now I'm going to review that for you. So activity table and then the network diagram. So here's your formula right there. So translating the project activity table into the related network diagram is difficult. So where's my pointer? Now here. So the average activity time for each activity is calculated by using this equation. Okay, this is your shortest, longest, and that's your standard, and divided by 6. So now we're going to get into activity A right there. So you go to the table, to the activity A line, okay, and then put your shortest, your longest, and then you put right here your most likely one, which is your standard. I call it standard. And then you're going to add it up. So you got 36 divided by 6 is you're going to get 6. Okay, so this is how you calculate. Make sure you practice this formula with all the lines that there's in the word. Okay, then go down. Here is your complex, okay, your network diagram. I'm going to give you the table, and you should be able to come up with this, a draw. And don't forget to put all the times that there's in the wall right there, okay? And then make sure they don't cross to each other. So you got to draw little by little. Okay, the dummy is not doing nothing, so you go with the dash line, don't forget that. And here another dummy right there. Okay, so this is your network diagram for your complex project. Okay, so if you have a real big one, you have like, let's say, electric generating power plant, you've got it. Okay, so you have a big blueprint right there in your system that you have to use a 1 or 2 or 3 monitors right at your desk. Okay, so that's how we're doing. Anyway, so the average project time T, more accurately annotated as mu T, okay, in a probability environment, is now 64 weeks in this example over a single critical path of activity. So here, this is your critical path. So every time we talk about, where's my pointer? So here, but talk about the critical, but we are looking at the longest, L-O-N-G-E-S-T. So your longest path. So that is going to go right here, your A, and then we're going to cross the dummy right there, 1, okay? We have 2 dummies, so dummy 1 and 2. Then we're going to go F, and then we're going to go G right here, and then we're going to go M, and then we're going to go S, okay, right there. And then we're going to go U right here, and then X to the end of the project, okay? So this is our target right there, instead of going the other way around, yeah? So now let's go back to here. Let me erase this for you. So go down. Okay, so the project, we're going to start getting our variance. You already know how to do it. Do your, get back all the way to the handout and get your variance, all right, and get that sigma square. This is just sub, it's telling you what we're calculating, so a big T. So that's your, okay, project variance right there. So that's, we calculated and kept 18.333 weeks. So we're going to square root that, so square root that. So here is my pointer. So square root this, and you're going to get standard deviation, yeah? So when you get the standard deviation, we got 4.2817 weeks, all right? So now let's go down. So this is some project management constant, and that's just a computation stuff going on. So average project time is 64 weeks right there. So that's our average It's always in the center. That's your normal curve anyway. So standard deviation, we have calculated it. So right here, 4.2817 right there. So you already know 64 plus this, and then 64 minus that is going to give you, okay, your minimum and maximum. So the project is visualized as normal distribution in this example. So the bell curve right there here, and your midpoint is 64, the standard deviation is right here. Yeah, it's just reiterating this thing. All right, so let's go down. Let me erase this. All right, so now questions. So here are questions of concern to project management. Question 1 and 2 we've got. So let's start with 1. So the very first question is asking you what is the probability of completing the project in, we want it done 67 weeks. Okay, give me the percentage that it can be done in 67 weeks. So we're going to give them the percentage that it can be done in 67 weeks. So we call Z. I'm going to use our standard formula, okay, and this is your mean right there, so put your mean 64. I'm going to draw this back for you again, that comes from right here, a 64 right there, and then you have your 67, okay, that's your maximum right there, and then divided by, which is right here. I'm going to link it back so you can see where it come from your question, yeah, and then because we're looking at that. And this I see like how this text word is wrong right there. So this got to be actually 67, okay? Because we're looking for Z67. So anyway, I'm going to change it so you won't see it. So Z67 67 weeks minus it, okay? That's just getting the difference right there, and then divided by the standard deviation. So you're going to get like 70%, yeah, about 70%. So now get the Z value, go all the way down to your, I give you the website, okay, in one of the slides. So you go to your normal distribution table and then put this, all right, and look for that number in your table, okay. You can also use your statistics textbook, go all the way down to your back of your textbook, and you're going to see a table. So if you still have your high school, okay, stat, if you have taken that, you're going to get the table from there. We call that Z table, okay? If you don't have anything, just Google it and it's going to come out Z table. And then we're going to go there, and the Z0.7 encloses this area. You get the area underneath of that, and you're going to get 0.2580. The midpoint is 50%. So you're going to add the 50%, so we know where our area is. So the area is going to come all the way and then cut out somewhere around here. Yeah, okay, and that is going to give you 76%. So we have about 26 from here to there, yeah? So from here to here is 50. So altogether you get 76. So that's how you calculate it. So this is rounding 75, 80, so you get 76%, okay? So that's the area under this part right here. So let's go back there. I'm gonna erase my mess here. All right, so this is how we calculate the probability. In other words, is what is the percentage that we can finish the project, maintenance project, in 67 weeks. Okay, so let's go down. Okay, so question 2 is asking you, okay, what about 69? Okay, we want to get the probability, and here this time, see, will be over 69 weeks. So here we're going to do the same thing and use your Z, and then we have 64 as our median. Okay, not what we're looking is 69, so let's just say it right there, and it's a over, so we're not trying to get the area on this side. Okay, so here this side is under, and then this side, sorry, and this side is over. Okay, so we have two area if you look at it. So I'm going to spot it right here, little dot right there. So the dotted area is every time you have a cutoff here, and the cutoff is going to give you like 69 week or 65 or 7, okay, under, okay, before, or you can use it before 69, you will be looking for this area. If we say like after or over 69, you'll be looking at this area. Okay, so we're trying to get this little area right there this time. So I'm going to erase this and redraw that for you. So now we're going to start back, and we're looking at 69. So we will back here and then draw and then cut here. Your average is 64 right here, and then your 69 is right here, and we're looking for that area. Why? It's because of this word in your question, over. Okay, so now I'm going to put the 69 right here for this cutoff, which is this point, because this point is 64. Okay, so put that in, you calculate it, you got 1.168, and then you go to Z, and then you got your area from your Z table, right? And then this site again, all right, is 50. So therefore, from here to the end is also 50. Yeah, and we know this little area, okay, this white one is this, okay, which is this one. I was to go here, and actually this is not here. Anyways, this is representing that area, okay, because from 64 to 69 is this area. So from here to here is 50, so 50 minus that is going to give you this. So 50 is from here to here, the whole thing, and then that is this thing, so therefore we get the area over, okay, 69. So you minus it right here. I'm going to point it out for you, so you get the 0.1210, and that's about, right, 12%. Okay, so now I'm going to go back here, and then erase this. There we go again. This is a little bit difficult to erase, but that's all right. Here we go, here we go. All right, so let's go next one. So now we come into computer programs. So computer programs are easy because you don't have to do step by step anymore. Just all you have to just feed the data and it's going to give you the result. So here, so 816, so BIGEX project, okay, big X. So activity table input. So we're putting this, feeding the data, okay, to your QSB. So QSB is nothing but it's just a software that we use. That's a quantitative systems for business. Okay, that's why we use quantitative system to calculate everything that we want to know about the project, your cost, your time. Okay, and the one that they're not showing is the one they always hide, and that is, you know, the money that the company is making if you can bring down the maintenance project, okay, to the shortest possible project length. Okay, so they never tell you that. Okay, that information is always hidden. Even the middle manager, you don't know that. That's always come directly from the upper management, and upper management usually safeguard how much money they're making. They never tell you anything. So every meeting you've got, okay, is always concentrating. So this is our medium, okay, middle management, this is our upper management, and here is our labor. So this is the organizational chain is going right there. You know nothing of how much the company is making right there unless you ask, or they like you and they will share you that information. You usually go to that meeting and then they're just going to ask you like, can you finish this one, this one, this one, and that one within that time. That's it. Yeah. But if you're right here, okay, so these are us, like the quality system, okay, we gotta calculate how much are we gonna make out of the production, and then say like, hey, you know, we're gonna make this one 2 weeks, can you do that? So you go down information, and they're gonna come down and ask you, hey, can you do that? So you go and work with your team right there, your labor, and they say, hey, can we push it? I'm gonna give you this amount of money, can you do that? And they're just looking at that, and oh yeah, I love this bonus, I'm gonna do it, yeah. And because $2,000 for a family, that means a lot for a normal family. $2,000 for a corporation is nothing. Okay, and just like a one minute of their spending time right there, but that's a lot for your family, right? And you can get down payment for your car or whatever. That means a lot of stuff right in there. So anyway, so you're like looking at, oh yes, we can do it, and you're gonna put your blood right into the app and bring the system back up, and then they're making that amount of money right there. Yeah. Anyways, you get it. So now we're gonna use this system, quantitative system for business, QSB. So if you're between middle and upper management, or you own the company, or you are the son and daughter of the company owner or whatever, you will have this kind of system and you will be knowing inside out of what's going on, yeah, especially money wise. Okay, now this is your Gantt chart. That's just like showing you, okay, this talking about our project completion time right there. So this is the example 64 weeks right here. So you know how to do the Gantt chart. So go all the way back to the first one, yeah. Then this one is just showing you the activity on node, okay, network diagram of your QSB. So these are, you don't have to do it with your hand. They're just like you feed the data to your system, and then that software QSB, all right, is going to spit it out for you. And you got a nice printout data right there. All you have to just feed the data to your system, and your system QSB is going to give you the result automatically. So here it just is showing you the probability analysis, okay, for big X using software is going to spit out this type of data, and you're going to see it's a little bit different from your hand, okay, calculating. So the difference is right here. So 67 with 75, and here is like 69 with getting like 87 right there, okay. So solution 1 and then solution 2. So you're going to take this out of 1, which is 100%, because you're looking at the over. So 87 minus, 100 minus 87 is going to give you around, okay, your 12%, 13%, right? So anyway, that's just studying the comparison with the human calculation, okay, and this is your machine calculation. Machine is always perfect because it contains intelligence, cumulative intelligence, or human logics, alright, or design into the machine, so you can rely on it unless somebody go and break the entire machine. Okay, at that time you need the human. Alright, so let's come back into here. So activity on node network diagram convention. It's just showing you your WinS QSB, and you input the data right in there. Okay, so that's just the project problem right in here. So this is your time, that's your predecessor. Okay, this is your activity, and then those are just a number for coded activity. So you know these activities have their own description right there. So here, activity on network diagram convention. So most computer software programs are part in CPM network analysis. Gonna print out the activity on node network diagram solution. So that's then we have your more computer printout. So these are just a printout, just showing you. You only have to just look at it one time, or you know that, oh, that's from your WinQSB activity. Okay, output. The same example, our construction of a manufacturing plant that we use in this textbook. Okay, so now I'm on 47 out of 49. So, okay, that's a lot of material in unit 8. So anyway, just take it slowly, okay? You can pause the video and then listen to whenever you wanna. Make sure you listen though, otherwise you'll be missing out on everything. So anyways, I'll go back here to the related network diagram printout. Looks like this, yeah? So that's just project completion time at 45 weeks, giving you all of this. So if you carefully look at it, it's a little bit different from the hand-drawn network diagram. So here is your A, and then B right there, and C right there, D, E. Okay, so you know where the activities are. And then here is your week. Okay, that's your start, and then that's your finish. So that's your E, all right, S, and then this is your, okay, E, and then F, all right, finish. So there we go, and then go down the next one. So the QSB project analysis solution diagram, okay, is presented right here. So this is a solution table given out to you, connected to your diagram in the previous slide. So here you get the same thing, no activity, and then your critical path. If that critical path is going to say yes, 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 so you know it's going A and then C, and it's going to go E and then F, and then it's going to go I. Okay, so that's how you read the printout sheet from your machine. And then here is your completion time, this is 45, and here is your ES and the EF, and that's your LS and then LF right there. Okay, these are your select times, so about the same thing, okay, as your hand-drawn table. So then go down, and then we have this, so our final slide. Okay, that's your manual forward backwards, again, past procedure. So this is a printout of our network diagram, which is a bit different because they called that the activity on node network diagram, which is a little bit different from our hand-drawn well, like this. Okay, so this is a hand-drawn, the traditional way of doing it. So here's a computer print on a nice little chart right there that you can see. So here's your start, and you have activity A here, and then you have your activity B right there, and this is your ES. Okay, so the starting and then the finish. Okay, is right there, and then here your start and then your finish. Your start, your finish, your start, and then your finish. Okay, these are just like showing you different ways of writing or drawing the diagram, but this is a machine drawn. Yeah, so the only thing that I have to point out right here, if you look at this, so I'm going to give you the one thing that is extra right here. That's just like showing you the difference. Okay, so that's telling you the activity F is going to spend 8 weeks, activity I is going to spend 5 weeks, activity H is going to spend 8 weeks, and you can get the difference of that. Okay, so 40 minus 32 is going to give you 8, because that's the start point and that's your end. Okay, well, that's it for Unit 8. And make sure you again, I will remind you again, you have to study, yeah? If you study, your grade is gonna go up. If you don't study, I don't know. So that's as simple as 1, 2, 3, okay? So make sure you do your job. And we have only about 4 weeks to final. Okay, I'm gonna close right here.